welcome to this workshop on caching. So, to get started, one question: who of you did something with caching on HTTP layer before? Okay. The others don't know about it or never worked with it. So the problem we're trying to solve is usually things are just horribly slow, and let me try to have less echo. Better? Yeah. So things are slow. Solution: install Varnish, then configure Varnish to run on the port 80, which is like this default port for web requests. Restart things, and you're done. Okay, so it was a pleasure. See you. Except a lot of things can go wrong, of course. Otherwise, we wouldn't need to do a workshop about it. And when you're lucky, what goes wrong is that things don't get cached, and actually you have this Varnish, but it's not doing anything. It's ignoring all the things and just passing them through. That's when you're lucky. When you're unlucky, it will cache things that actually shouldn't be cached, and then people will see other people's pages, for example, or things just don't update anymore, all these kind of problems. So for this workshop, I'm first going to do a short refresher on HTTP, because caching really, if you get that part of HTTP, it's not that hard. If you don't get it, it's weird black magic and you don't know what's going on. Because HTTP is used to configure what the caching should do. And after that, we will look at Varnish, and then we will go to some advanced topics. So, first thing, where does the caching happen, the caching that we talk about today? There is the internet, and then your systems come in, where you have this, the red circled thing is the caching proxy, so it sits in front of your web server, and every request that goes to the web server actually goes to that cache. The cache looks, oh, do I have the answer? If not, it asks the web server, gets the result back, maybe stores the answer, so that next time the request comes in, it can say, oh, I already know the answer, reply, and that's really when you have the cache hit, when it's really fast. So, who of you has seen this before? Does that look familiar? Okay, so really HTTP is not that complicated. You have the information, what you want to do, if you want to get something or post something. You have some path. It's like the request path that you have. This thing, that's when you have a response, it's saying whether the response was successful. There is these numeric codes, the 404, that means, oh, nothing was found. Or a 500, which means, oh, the server had a problem. And then you have this, some very simple key value hash map thing that gives information. And in a moment we will see that caching information is also in this. And then you have the body, which is what it's like all about actually, but today we don't care what the body is. It really doesn't matter for caching. You want to cache the body, but you don't look at the body to decide if you can cache it or not. Yeah, so that's the various operations. You can invent your own. And the status codes, which, yeah, basically it's this, everything with a 2 means it's good, everything with a 3 is a redirection, everything with a 4 is a mistake by the client, and everything with a 5 is some problem on the server side. Right. And we will see in a moment why we had to refresh that. So on caching, there is different ways you can do caching, because the basic thing is you have some data, and then your Varnish or whatever you're using needs to decide, A, can I even cache that? And 2, when it gets the next request, is my cache still valid? Is it still okay to give that answer? Because if you wouldn't care about that, then once something is in the cache, it would stay forever, which probably is not what you want. And there is 2 basic models. One is the expiration model, and the other one we call validation. So with the expiration, so this would be HTTP headers. There is 2 ways of expressing it. One is the modern way of HTTP 1.1, and the other one is the legacy way of HTTP 1.0. So expires you shouldn't really use. But the cache control is what you want to use. And there you specify how old may this content be. There is actually 2 things. There is this smax age and the max age. The smax age is the S stands for shared. So it's for things that share data with many people. And max age is what your browser is going to look at. And if you specify both, what we do here is we tell any cache that is in the middle, you can cache that for 1 hour, and then we tell the client that he can cache that for 900 seconds, which would be like 15 minutes, if I'm not mistaken. And Varnish is following this order of looking at the response to decide on caching. If it sees, oh, there is smax age, it takes that. If there is max age only, it will take that. And if there is an expires header but no cache control header, it will use that. But as said, you shouldn't really use that if you can ever avoid it. And then if nothing is specified at all, there is a default value which, if you don't change it, is going to be 2 minutes. So if you just have an empty response without any information, it will say, well, I don't know, I'm going to keep that for 2 minutes, let's see. Which may or may not be what you want. So let's look at the first exercise and find out if the environment works. So the workshop is the HTTP cache folder. And a second, here. What you want to run is this thing. When you're... Can I make it a bigger font? Oh, well, yes. It looks already pretty big on my machine, but so inside this folder, you want to run this enable Varnish. What it does is it moves Varnish to port 80 and moves Apache away to some other port. And at the end of this workshop, please go run. Sorry.
Which? I don't have an installation folder.
Are you on the PHP Summer Camp branch? That is weird, because if you install the machine, it should have gone there. But yeah, so you should be on this PHP Summer Camp branch, and maybe do a git pull just in case. And after the workshop, or tomorrow morning, when nothing works and everybody's confused, do this to move Apache back to port 80. Otherwise, you will do your exercises tomorrow going through Varnish, which is maybe having side effects, unless these exercises were all developed with caching in mind. Does that work? Did you... Does it work? Yes? No? Not yet? Huh?
It doesn't complain.
Okay. Well, let's see. Sorry. So let's go to this. I can't make this bigger, I'm afraid, the URL, but it's http://cache.phpsc. And then you should get to see this thing. Who sees this? Good. Who doesn't? So maybe you can have a look with them. Thank you. So Michele is my co-host, trying to help people that get stuck. And the first exercise would be that you look at this no info file. So you can find that here. And in the source code, oops. Nope. In the source code, everything is in this web folder. So what we do here is we send a response without any headers, without any information, just with the date. I'm always going to use the date as a content because it's very easy with the date to see, or with the timestamp, to see if the content was cached or not. So what you want to notice is when you reload this thing, it doesn't change, even though the time would advance. If this thing changes, then the enable Varnish thing didn't work out. Do you see that? Good. And now let's look at it like this. So for the workshop, we're going to use a lot of curl. Curl is one command line HTTP client. And the nice thing when you call it with these parameters like this, it's going to show all the headers. So here we immediately see what exactly we're applying. And that's very useful when debugging, when we develop for caching. So some things that we see here, that's something that in the Varnish configuration I added, that it outputs this information so that we see what TTL it's using, what time to live. We also see this, the age, which when the age gets to 120, or actually 121, it won't be delivered anymore, and we will get a fresh timestamp. And I also added this to the configuration of Varnish so that it outputs whether we had a cache hit or a cache miss. So now if I'm doing that again, I think I talked for long enough to have it expired. Yes, I did. So now we have an age of 0, a cache miss, and the timestamp changed. You see that here. And as I said, this happens because we didn't specify anything, so Varnish is going to take its default 2-minute caching. Now to do something more interesting, open the exercises expiration file and try to send a header to make that cached, because right now it's doing the same as the other one, so it's going to be cached for 2 minutes. But edit that file and send a header I guess I'm just going to show the solution so you don't have to look it up for this one. So that's the PHP function to set a header. And what we want to set is a cache control information. And here we would set it to 10 seconds. So try to do that and then either use curl to fetch that page or load it in the browser. And you should see with curl, you should see how the age, if you fetch it and fetch it and fetch it, you see how the age is counting up until 10, and then it goes back to 0. When you loaded it before adding that header, then it's going to be in the cache, and that's actually a very important lesson about the caching. Once it's in there, the cache won't notice if you change the file. It doesn't watch any PHP files and figure it out for himself. We will see other options later, but the very easiest is you just do this, sudo service varnish restart. And that's just going to restart the Varnish server. And because Varnish doesn't store caches on a file system or anything, it's going to forget about everything and you start fresh. And it's actually, while developing, I tend to do that because then I'm really sure that I don't have weird things in the cache that I didn't expect. Does that work for everybody? Who is still trying to get it to work? Trying to get it to work, or does it work?
It doesn't. It always shows the same time.
Yes, that's good.
Oh, sorry, it's the new time.
Okay, and then you probably don't. The script to switch to Varnish didn't work probably.
Looked like it worked.
Okay. Do you have something on port 8888? Because that is where Apache is now sitting. You can try to just add here, yeah.
This one?
No, 8888. Otherwise you see Jenkins. That works? Okay.
So it's working in my browser, but it's working on a command line.
Okay.
And access it with the browser, the Xcache TTL is 0. TTL header.
Then it might be that you have a cookie in the request, for example.
Yeah.
Then try to delete all cookies for that domain.
Now it's working.
Okay, cool. Yeah, I think we get to that in a moment. But if you have cookies in your request, nothing is gonna be cached ever, because Varnish sees cookies, things like, oh, individual content, I don't touch that. Okay, so let's move on. And if it didn't work, try to raise Michele's attention and he can help you. Do you want help? Or no? Yes? Help? Are you fine?
No, it's not still on.
Michele, maybe you can help him. Okay. So there was cache expiration. When you specify cache will be valid for 2 minutes, for 5 minutes, for 20 hours, whatever you want. Now, cache validation is usually done with the E tag, which is you just send with the response, you send some hash value, which for HTTP it's transparent. It doesn't know what it means. It's just some value. But Varnish will store that with the cache. And when a browser sees an E tag in a response, it will also keep that. and it will send the next request with a header saying if non-match, which means give me that content unless nothing changed since you got that tag. If it still has the same tag, then please don't give it to me. Just tell me that it didn't modify. And with this, in terms of if that happens in Varnish, you save bandwidth. For Varnish, it wouldn't matter if it would have to reply the content from the cache. It wouldn't really care, but you waste some bandwidth, which depending on the size and depending on if you do mobile or something where bandwidth matters, might be relevant. But of course, if you can do that in your application, it gets even more interesting because the application, maybe it's a heavy thing doing a lot of things, but at the beginning of the application, if you can check that hash and somehow already know if the response will still have the same hash or not, then you could save a lot of effort on the application. Okay, so we have an exercise for that as well. Let's look at the etag file and then try to run this curl command so that you see if it works. Oh, and when I have Varnish LO here, just use http cache.php sc, of course. So in this file you will need to add something which might want to look like this. Only if you want to go with the example command line, make an etag of ABC, so or whatever, just copy the etag you put into the curl command so that you see if it works. So to show you what it does, by the way, you have this solutions folder. If you want to not learn too much, you can try to look there like from the start, but I recommend you don't. But afterwards, have a look there to see the solution, especially if it didn't work for you. So, whoops. No. That didn't make much sense because I wanted to do this. Right. So I did my first request and I got a miss, obviously, because Varnish doesn't know about this thing yet. And interestingly enough, it already told me it's not modified. So what Varnish did, it was doing a request to the backend, got a reply back, and then saw at the etag, oh, actually, it's the same etag, so it still doesn't send me the response body. So it still saved the bandwidth, and at the same time, the cache is now refreshed. And I talked for too long. If I do that quicker, repeatedly, then we start getting cache hits as well.
But still, the web server will get a hit because Varnish will ask for the etag.
In this case, no. Varnish is not going to do a if modified since request to the backend if it has something in the cache. However, actually, so if the time to live is not expired, then it won't do the request to the backend. But if it still has it in the cache, but the time to live expired, but it's still there, it will attempt this if modified since to save my backend the effort. Okay, there's another thing which is basically the same as the e-tag, only it works with dates, which the only reason to support that is for legacy browsers that don't support e-tags, basically, or legacy other clients of your application. Because it's really doing the same thing, but with the added hassle of date comparison and possible clock skews. So we skip that exercise. And that's basically what I said. If you ever use it and want Varnish to cache, even though you have this last modified, you need to create the date in the right, correct format. This one doesn't work. You need to have the format with this word GMT in it. Otherwise, Varnish is like, oh, I don't know that. I will ignore last modified, which means it can't validate on the date anymore. Just so when you debug your application with a browser and you have caching, so the browser, if you set this max age, it will not even talk to your server. And that's also important. If you accidentally tell people like the front page of my website can be cached for a year, then all the people that see that page load it once, and then the browser is not going to refetch that when they again click on some link and come to your homepage for a year. And you have no way of telling them to forget about this information. So you have to be careful what you tell the browser. And if you have this e-tag or last modified header and the cache has expired, then the browser is sending the request with the if non-match, if modified since. If you do a control reload, then at least Firefox and Chrome will not look at their local cache to say like, oh, this is still in my cache. They ignore the time to live, but they still will send this if modified since header. And browsers also have usually this thing to really like force them to reload. So on Chrome, well, I guess it also depends. If you have a Mac, it's probably other keystrokes, but there is something where you tell them like, forget about your local cache for this request, just fetch it again. Then there is pages you don't want to cache, and there is a couple of things you can put in the header for Varnish. Having s max age equal to 0 means the time to live is 0, so it doesn't get cached. You can also have this no cache keyword, which means it shouldn't be cached ever. And you have this private keyword, which is kind of more implicit in what you intend to happen. But at least Varnish 4, if any of these three is set, it will not cache anymore. So I would have an exercise on that as well, but don't know if you want to do it or if we should move on so that we get to more complicated things. Move on? Okay. Yeah, and those who want to see, look at the solution of this no cache. Basically, it's setting a header like this, and then it's gonna not cache. When does Varnish cache? When you, well, actually you can configure what it does pretty much everything, but by default, it's only going to cache get and head requests, and I don't think you can change that, and it wouldn't make sense because when you post something, you want to change something, and you cannot cache the response to a request that would change the state on the server side. It doesn't make sense. As soon as there is a cookie or an authorization header, which is this thing when you have basic authentication with the pop-up with the username and password that is done by the browser, as soon as you have these headers, Varnish will stop caching by default because it says, whoop, that's probably like protected content or personalized content. So unless you're specifically telling me to, I won't cache that. Also, if there is a response setting a new cookie, it's not cached, which most of the time is probably what you want, because not everybody should have the same session ID, for example. And finally, it only caches some response status, namely the successful ones and 404, which is not found, because it assumes, well, if it isn't found, it's not found for everybody. Unless, of course, it would say, if you have this no cache in the header or anything, then it never caches. This is just if there is no other instructions. But it will never cache, for example, the server-side errors, which is a good thing because maybe it just failed once because of some random thing and you don't want the cached error page for a long time. Let's look at this cookie thing. So there is this cookie PHP which will set you a cookie, and when you request that, you will see there is cache miss every time a cache miss, because we always set a new cookie. And so if we send a request to something that would be cached normally, but we add a cookie, we also get misses. If I would remove this instruction for curl to not send a cookie, now it's not in the cache, and now we have a hit. And as soon as I send the cookie, I get a miss. Then one more thing, variants. That's solving the problem when you have the same information in different encodings. So, for example, so here we would vary on the formatting. So in the request, we send this accept header saying, I want JSON or I want XML. And the server, who respects that encoding information, will tell Varnish, this response actually depends on the header saying what encoding is accepted, because both times we have the same URL. And a lot of people also do just like /resource.xml and .json, and then you wouldn't need to care about this, because then it's just two different URLs. But from a design perspective, it makes a lot of sense to do it like this. So if you do it, you use this vary header. Yeah, there would be an example on that, but I'm going to skip that as well and move on to Varnish. What are we doing with the time? Okay. Is so far everything okay? Everything clear? Or questions, confusion? No? Don't hesitate to interrupt me if I'm going too fast or if something is not clear. So the Varnish Proxy, as we said, it's a reverse proxy sitting in front of your web server. It is configured with a domain-specific language called VCL. So it's not so much a configuration file, but more like a programming language that's very specific to just configuring a caching server. The way it works is as a state machine. That's important when you start to customize it, when you start to configure it. you want to understand how it goes from one state to the other while processing a request. And there is, for each of these states, there is a hook function. So that bit looks a bit like Drupal. You just implement that function in your configuration file, and if it's there, it will be called. And then the configuration on startup of Varnish, it's compiled. It's actually translated to C code and then compiled and linked with the Varnish server so that it's like as fast as possible. And I don't have any numbers to impress you with, but it's really, really fast when Varnish can have a cache hit, or also when it goes through to the backend, the added overhead is really, really small. Varnish also can do some other tricks, like acting as a load balancer, having several backends, or deciding based on domains or paths to go to one backend or another. But for that, I think, I'm not going to show that. And I think it really depends. If you just have like 1-2 cases, it can make sense to use it. But if you have like really a big need for a load balancer, then maybe you want to use a dedicated tool for load balancing. So this is this state machine. And basically, you have the request coming in. And there is a hook function called VCL receive. So Varnish loves to shorten everything. So it's whatever. You can implement that function to alter a request when it comes in before Varnish does any decisions. And actually, with the hook, we'll see a bit of an example later. Each of these functions can return the next state. So the state where Varnish should go now with this request. And if it doesn't, Varnish falls back to the default implementation, which will do this default behavior. And it's actually quite nice to read this default behavior VCL, because it really expresses in that configuration language what the default behavior is. You will see that if there is a cookie, it stops caching and all these things you see in that configuration. So the receive function has to decide whether it wants to attempt a cache lookup or whether it wants to pass to the backend. And passing typically happens when you have a post request, when there is a cookie in the request. Varnish would say, well, I don't even try to look at the cache. It doesn't matter. I know that I have to go to the backend. If it goes to the cache, there is this function VCL hash, which determines how to, like what the key in the cache is to find a possible response to a request. So the hash has to be calculated on information you have in the request. It can't use anything that's only on the response, obviously, because there is no response yet. And typically that would be domain name, so the host header, and the URL that was requested. But in some cases, you might want to add things there or do it differently. And then it tries to see that, to find that hash in the cache. And it will also, at that point, respect the vary information, because the hash will be the same regardless of what accept header, for example, you had. But it will then find, oh, there is like several entries because there is this vary information, and then it will match that and find out if it has the matching one. And if it doesn't, it calls this VCL miss, which means, oh, you had a cache miss. Then you have another one called backend fetch, which is called right before Varnish is talking to your web server to get content. Then there is a backend response, which can decide between delivering that response or a special case setting this value on the response to say it's not cacheable, and then it won't be put in the cache. And then if you had deliver, it goes to the cache, and you have this VCL hit, which is executed also if actually it wasn't a cache hit in the sense that it was in the cache already, but it was put into the cache. So in both cases, you end up in VCL hit. And then you go to VCL deliver, which is like always the last step where you typically you might want to remove some headers that you only used internally in Varnish. And with this VCL, it's quite powerful. You simply say like add this header, remove this, rewrite this, and it just does what you tell it, so you can really break the application in the sense of browsers starting to cache random things or caches mixed up. So think about what you do and then test what you did. What you can do in VCL is read and write values of the HTTP header. You have conditions, like if, but there is no loops. It's not a full programming language. You have these functions for state change. You have regular expressions. You can change the cache, so you can, for example, invalidate things in a cache. The functions have no return values. You can just change the state. You have no variables, because that wouldn't even make sense. It's a state machine. What you can do is add information into headers. And because Varnish is operating like really highly parallel, it wants to execute your configuration on multiple requests in parallel. So it cannot really deal with any application state. So everything is on this request, and if you need to have any information that you need later when handling the next hook function, put it in a header. And then if you want to, you can also write some inline C code, which quickly looks quite horrible to me, but it's an option if there is no other way to do something. And as said before, if you restart it, it will empty its cache, and also it will read the configuration. There is, in newer versions of Varnish, there is also a reload, which, or actually I think it depends on the distribution of like the operating system, how you installed it, whether it has this reload or not. But that's a way to just load the configuration without forgetting about cached things. And if you have like really high load, then you want to reload and not forget the whole cache. If you can afford it, I would just restart it to get it like cleaned up and forget about old things. So this is a fragment of VCL, which we would use to know so the first one, we would, in the backend response, we have this information on the TTL, which is used inside Varnish, but it's not sent to the client. And if we say .http, so that's the headers, dot something, here you can just make up a name that you want, and it will add that header. And the same here in the deliver. You have the cache object, which is called opt in the VCL, and you can check whether it had hits on it, and then this means this request was a hit, and if it had no hit, it was a miss. And then we set these headers so that when debugging, we can see what happened. So actually, that would be how to handle this load balancer or like gateway thing when you have different backends. You would configure on which IP they run, on which port, and here we have a regular expression with this tilde sign, this squiggly line, means do a regular expression match. So everything that starts with an archive in the URL will send to the legacy application, and the rest goes to the default application. Or remove cookies. If you never have any login on your application, this can make sense. Just get rid of cookies. What we do here actually is a bit cheating, because we say if there is cookies and we ask for a path within cache, we don't want the cookie header to be considered, so we remove it. Problem with that is that there is a path called cache, is actually something your application knows, not something that Varnish should know about. You're mixing responsibilities. So this example, you can look at the, wait a second, right. So let's try this. And just put this into the VCL. You will find that in here, config. And this one is the main configuration file, which includes this common. And here we have commented out a couple of examples. You can just paste below these. We can paste this thing.
Where can we copy it?
Well, not copy. I can copy, you can't. But it's not that much. So this is when a request comes in. Here we say if there is a cookie header, then remove that cookie header. And once you have typed that in, you will need to restart Varnish again. Oops. Okay, I didn't do that well. Uh-oh, what did I do?
Well, it's good to show this.
Hmm?
It was good to show this a few seconds more.
Sorry, yeah. Well, the problem is that I have a mistake in it, because it's actually not called remove, apparently. I think that was Varnish 3. Ah, okay.
I think it's unset.
It would be unset, yes. Yeah, that looks better. So if there is this thing, unset it. And now, if we go to this cookie thing, why is that? Ah, it's always setting a cookie. Maybe let's try with this now. Right. So now we are sending a request with a cookie, but since we remove all cookies in Varnish, we get this cache hit when the cache is not expired. And once that worked, please remove that again, because otherwise the following examples won't work at all. Does it work? Worked? Hmm? So this one, it's a bit more involved. It's more to show you an example of inline C. Yes?
What exactly does it remove in the response header?
Wait. Apparently you have to speak to the microphone.
Can you show your curl response again?
Sorry, that?
Can you show your curl response again?
Curl, yes. What it removed was from the request, I was sending a request which said, I have this cookie header.
Yeah.
And the VCL was telling to forget about the cookie in the request. Because if the request comes with a cookie, Varnish will not cache it. And and we removed that cookie so that Varnish actually will cache it. And the good thing is that at least the backend will not see the cookie, so it won't accidentally use the cookie to do something. So at least, the only thing that could happen is that your developers are confused why there is no cookie, even though you send a cookie.
Yeah, but does backend still sends a set cookie header? Isn't that the same?
No, that's not the same. When the backend is setting a cookie, that's in the response.
Yeah, so it's still caching that, or no? Shouldn't, right?
It's not cached. When you request the page that sets a cookie.
You're testing it with expiration.php.
Yeah, I tested. Okay. I first tried to test it with a page which set the cookie, and that didn't work.
That was confusing for me. Yeah,
okay. Sorry.
All right.
Yeah, you could also write the similar thing to unset the set cookie header if you want to, but then it would really make a lot more sense to fix your application to not set the cookie if you don't want that to happen. So the next example with this inline C code is about the smaxh header actually tells every proxy that is out there on the internet. It could be like an outgoing proxy in an organization. It tells them, oh, you can cache that for some time. And sometimes you don't want the same cache lifetime on your Varnish than on some random things on the internet, because your Varnish, you can still go to it and remove things. If something went wrong, you can restart Varnish and make it forget about things. So the example here, we would send this custom header called X reverse proxy TTL, but that's just the name. You will see that name here. We could use a different name. And set it to some value so that we don't set a smaxh that the rest of the internet would look at. And then there is some C code to make that happen, because in VCL you cannot set a header to a dynamic. You can't set the cache lifetime dynamically based on a header value. So we have to do that with inline C. And that's an example I found in the Varnish documentation. It's not like, it's very likely that you would write C code for configuring your Varnish all the time. I don't know, do you want to see that exercise or shall we move on? Try it or not? Quiz for trying.
What does it do?
It would be trying out this thing. Try it. Or move on. Go further. Move on. Move on. Who? The rest?
We can move on.
Okay, let's move on. So, as I said, with VCL you can change headers of the request, of the response. You can decide if things can be cached. We didn't see an example, but you can also change the URL of a request. You can do a lot of things, but actually be sure that your application first does things right. So you shouldn't fix your application in the Varnish configuration and say like, oh, it doesn't send cache headers, so I'm just going to put here, if the URL is like that, it can be cached, and if it's this, it can be cached a bit longer, and then we have to remove this header and do this thing. That's a really, really dangerous way of developing, because then you look at the PHP application or whatever your backend application is, and you don't see what's really going on, and you look at the VCL, you kind of don't know what it's doing, because it can get quite convoluted like this. And when you change something in the backend, then maybe the paths are called different, or the header is a bit different, and then suddenly things stop working. So make your application behave properly, and then Varnish is not going to be very difficult. There is also some monitoring tools in Varnish that I quickly want to mention. There is 3 command line tools. One that shows you basically like the current statistics, one that shows the top requests, and then one called Varnish Lock, which is basically a dumper of the whole traffic that is going on. So maybe try that. Just type Varnish Lock in the console and then take the browser and click on something and then look what happens in the console. And you will see it's extremely verbose. So like once you get used to how to read it, you can see everything that's going on, which is probably too much most of the time. But you can tell Varnish Lock to filter what you want to see. You can say, I only want to see the client requests, so that's the requests that come from a client to Varnish and the response to that. Or I only want to see the requests that Varnish is doing to the backend. And you can query on things like the request URL, everything that starts with exercises, or things like that. So you can limit what you see in the log if you want to debug something specifically. And most of the time you want to do that on some test system or on your local machine on a production server. It's basically impossible to get anything useful with Varnish Lock because there is just too much going on. Yeah, so lots and lots of things, but I think I will show it here because it's more readable. One thing to let's do one more request. So here you see there is some request. It started. It came from this IP. We had a get. We wanted this no info. It was that. So here we have rec is the request. So the request had this header. It asks for this host. It has a user agent and whatnot. And now I call receive. And we had this unset to remove the cookie. And then it goes to, it returned hash, meaning we can go to look in the cache because we had this unset. Then I think that's something of the default VCL. It's cleaning up this accept encoding to not to increase the chance that you have a cache hit. And then it actually calls the hash, which returned lookup. And we had a hit. It delivers. And then we get to this response. So everything that starts with a resp is in the response. So here we have all the headers and then some debug information. When you leave it open, the log, for a while, after a while, it periodically it will output this thing saying like, oh, I'm still here. So yeah, it takes a moment to get used to it. There is also brec and bresp when it talks to the backend. But still, it can be useful when you're like, what the fuck, why is it not working, what's happening, to see what it's exactly doing. So let's skip that and get to advanced topics. So the time for the break would be when? 15 minutes, yeah? Good. So let's look at cache invalidation, and probably then it's about time for the break. So, yeah, before we had cache validation and cache expiration, but in some situations you feel like, oh, I want to actually, it would be way more efficient if I just cache for a long time, and when I know that something is not valid anymore, I'm telling my cache to forget about it. And theoretically, it's awesome because you don't have this dilemma between if I put a too high lifetime, people see stale content. If it's too short, I waste efficiency because I have too many cache misses. But it's a tricky thing. It can go wrong. So one thing, before we really get to invalidation, properly speaking, is this thing, which you use for invalidating a cache on the browser. So when you send the link to the CSS files or JavaScript files of your application, in the web page, like there is this script tag, you would append something like question mark version equals whatever number or date or something. And then each time your assets change, you would change this number to something different. And then when you return the assets themselves, you can tell the browser, oh, you can cache that for a year, I don't care, keep it, don't ask me again. And then next time the user is loading the page and the assets changed, the string will be different. And then it will do the request again because what comes after the question mark is still part of what makes a cache different. But then for Varnish, what you can do, and if you can't change the URLs that are requested, is explicitly telling it to forget about things. And there is a bit of different ways of doing that. So one is purge, which means this exact URL has to be invalidated. Forget about that one. And this will also remove all variants of that. So if you had these accept headers. There's another one we call refresh, where we send the request to Varnish and say, please do that request as if you didn't have that thing in the cache. So it's doing the request, forcing to go to the backend, and then updating its cache. And the nice thing about that is that once the cache is never really empty, You won't have this moment when somebody does a request and the information is not in the cache, so it has to go to the backend. But your request is updating the cache, so the next request will just see the new content. The drawback is it doesn't work with variants because it can just like execute the exact request, including the accept headers. So if you have variants, that doesn't work. And then there is ban, which is much more flexible. It just, with this you can invalidate on any headers and on the request URL and say anything that matches some expression, like everything that is /posts, whatever, is going to be not valid anymore now. For all of them, you need to do some configuration in Varnish. For the purge, what you do, well, for all of them, what you want to do is this ACL thing, the access control list, which says who is allowed to send the request, because you don't want people on the internet deleting your cache. That would be a bit, making it a bit too easy for denial of service attacks. So we have this ACL saying only requests from localhost will be accepted. And we invent our own HTTP method, and say if the method is called purge, we check if you're allowed. If not, this thing is to abort the request. It means give a synthetic response out of Varnish, don't continue, don't talk with the backend, just abort. And otherwise, we switch to this specific or special state purge, which I didn't show on the diagram, but it's another state that you can go into, which means take this request and remove everything from the cache that matches this request. Let's try that. So in this configuration file in config varnish common, we have one that is called invalidation. So we remove the comment. We restart Varnish. Oops. And then from inside the box, you can run these. Well, actually, this thing you can also do in the browser, but this one you can't really do with the browser. And it's httpcache.phpsc, not Varnish hello. Right. When you send the purge request, did you get this response? Yes? Cool. So, so we would request the thing, its cache hits, then we purge, and we request again, next time it's a miss. So that's one way of invalidation. For the refresh, I have a demo because I think it goes a bit, would take too long to implement that yourself, which is in the invalidation folder. So, whoops, web invalidation. And here we have a page with a form, and on submission we post here, and basically we tell Varnish to forget about the cache. So here, now I still have the cookie, I think. Yeah, right. So now I don't have the cookie, but when I purge, swoop, it updates. And the same when I do a ban or a refresh. So this side is actually not very interesting. It's just this form that you have seen, and it's saying that this is cacheable. What is interesting is here, the update handler. So this is a PHP library. There is also a Symfony bundle, but the library and the bundle are separated, so you can also use it in other contexts. If it was a Symfony thing, you could use some services for that. Well, basically, you create some client that can talk to the cache server. You create this cache invalidator object with a client, and then we can talk to the invalidator. Well, so this is just some sanity check on the input, and then we check what was requested, and we have a function called invalidate path or refresh path, and then invalidate with a regular expression, and we just invalidate this invalidation URL. And we have to call flush, and then the client will send a request to the server. Okay? And as I said, banning happens on regular expressions. So when we look at this thing, these two, they only invalidate the thing called invalidation. If, for example, I would go here to index.php. That's not the same URL. It happens to be the same file behind, but Varnish doesn't know about Apache automatically finding the index.php. So if I purge that, now I moved, but I'm still on this old date. So it's 90840. I purge and go to the index. It's still that. Now if I ban, it changed. Because banning happened on everything that starts with invalidation. So it included this index.php. We have seen that. So on the banning, you shouldn't go crazy with that, because the way it works with the purge, Varnish can immediately discard that thing from the cache because it's just a lookup on a cache index. But banning, potentially, if you have, I don't know, 100,000 entries in your cache currently, and you want to ban on some regular expression, theoretically Varnish would have to go through the whole cache and check everything, which potentially would lock down the cache for seconds or minutes or whatever until it had looked at everything. So it doesn't do that, but instead it keeps a list of things that have been banned, and when it has a request and finds a cache hit, it compares with that list, because it thinks the list of bans is much smaller than the size of the cache. And once everything in the cache is newer than some entry in the ban list, it can discard the ban list entry because it knows nothing that was matched by that ban would be anymore in the cache. And then there is some background process that when Varnish is bored and has nothing to do, it goes through the cache and starts to check with this ban list to also remove things and eventually clean up the ban list, even if the content wasn't requested. But just to keep in mind, if you ban thousands of things every minute, you probably run into a problem. So one more thing you can do with banning, which can be quite cool, is tagging your cache. So far we always knew, okay, we want to invalidate this path called invalidation. And for some reason we knew it's going to be on that path. But imagine you have a CMS, you have lots of content objects or things in some database or whatever, and then you have pages that aggregate several of these objects and have a nice list of recent blog posts and the latest news and this and that. And whenever the title of any of these latest news changes, actually every page that is cached that was showing the latest news has to be updated. And one way to do that is cache tagging. And the idea is on the response of a page, you send a header where you list like the IDs or something of all the elements that were used on that page. And whenever you update one of the elements, you tell Varnish to invalidate everything that was tagged with that element. So you don't have to know on which page what element would be used. So we have this exercise. Let's say that's the last one before the break. So exercise tagging. The idea here is, I quickly first show you the application. Tagging, exercise, tagging. Here we are. Yeah, it's more optimized for the curl than for the browser. Whoops. Right, yeah, it only works with curl actually, not with the browser. But so what you can do is you can ask for this page, you can set some filter, and the tagging will go over all items, and if the filter matches or doesn't match, it removes them, and then all the things that were not filtered out will be returned. And the exercise would be to put the tags on the page of all the items that you still have. And then on the update script, we would want to invalidate by tag. So that when you play this sequence, you would really see the updated data after posting. So the question was for the tag invalidation system, if you would do that without the FOSS HTTP cache. Well, you can, but I wouldn't recommend trying to do it without, because it's not like it would be a heavy thing to have in your application.
Okay.
So, and there's actually a couple of things you can do wrong with the invalidation, because you should, and also with the tagging, you should be careful about the escaping. Well, depending on what you use for the tags, but if you happen to use the separator or happen to use something that has a meaning in a regular expression in your tag, if that's not escaped, you will suddenly not really do what you meant to do. So I think for that reason, it's worth to use it, but
Okay.
yeah. And actually, if you happen to use Symfony or something based on Symfony like Easy Publish, there is more integration than what I'm showing here, where it gets more convenient also to use it. Then you can configure this invalidator as a service, or you can even annotate your controller with tags and things like that. So then it gets really convenient. All right, I'd say it's time for the break. So if that thing works for you, take a break. If it doesn't, maybe take a break also, or ask me and I can help.